All right, welcome back, apes. And we were talking about plate tectonics and topography. This is the 8th screencast in the Chapter 2 series, the Earth's physical systems, matter, energy, and geology. So I had left off, we were coming close to the end with that, and I was telling you that the topography is going to alter the patterns of the rain, the wind, the currents, the heating, and the cooling of the earth. So this affects our different biomes that we have and is responsible for the 11 different biomes. It influences where certain animal species and plant species are going to live and be able to thrive. And because of those different biomes that we have, the different ecosystems and ecosystem services within that, then that's what is actually going to help shape our climate conditions, our biogeochemical cycles, and all of those that are connected to our living systems and food chains. We also have to consider the different types of rocks that are present. You know, you heard me say shale rock for the hydrofracking. So we need to know the different types of rock. And rock is any solid aggregation of minerals, so that means a collection of minerals. And a mineral is any element or inorganic compound that can be crystalline structure. It can have a specific chemical composition, and it can have distinct physical properties. You know, we can think of quartz as one of those examples. When we consider the types of rocks in an area, that's going to help us determine the type of soil, the soil characteristics, and we'll be doing a lab where we'll be testing sand and clay as part of the different soil characteristics, and this is going to influence what kind of plants are going to be able to grow in that area, and the types of plants are going to determine what type of animals are going to be in the area that depends on them. When we understand the rock cycle, it helps us to understand more about why we need to conserve our soils. We think of soil as being abundant, and it's really not. We have to sustain the use of our soils. They're so important to us, and we're going to see that in a later chapter. We also need to conserve those minerals. Our fossil fuels, huge. Our fossil fuels come from this, and we are a fossil fuel dependent society, and there are limits to our fossil fuels, and we're going to talk about the numbers in years of how much we have left of coal, natural gas, oil, those kinds of things, and not too much longer. I think I might have them mixed up, but I think coal is like 52 years away from being totally depleted, and our oil reserves are about 64 years of being depleted, and our natural gas is about 112 years away from being depleted. And these fossil fuels took thousands of years, hundreds of thousands of years to produce. So there's no way within our lifetime that we could produce those fuels. So it's significant that we get into renewable energy for that. And of course, other natural resources are influenced by the rock cycle. The rock cycle includes, and is not limited to, the heating of the planet, keeping heat, the melting of the rock for new rock formations, the cooling of the Earth's surface, the breaking and the reassembling of the rocks and minerals. And the breaking and reassembling really essential in forming the soil that we use to grow our plants. All right, so here is a great little graphic, and A, if we're taking a look at A, I see B, see here we go. A is over here at about 2 o'clock. This is the igneous rock, and this is formed when rock melts and the resulting magma or lava then cools. All right, B down here is sedimentary rock, and this is formed when rock is weathered and eroded, and the resulting sediments are compressed to form new rock. And then C, right here, is metamorphic rock, and this is formed when rock is subjected to intense heat and pressure underground. And what we're seeing is through these processes, each type of rock can be converted into either of the other two rocks. So igneous rock, just through pressure and heat, can be form metamorphic rock. And metamorphic rock, through weathering and erosion and transport and deposition, can form the sediments that igneous rock can also be converted into. Sedimentary rock, through regular weathering and erosion and transport and deposition, can also produce sediments as well, and under heat and pressure can go into metamorphic rock. We can melt this metamorphic rock and we can get lava and magma, and cool that down and we can get the igneous rock again. So that kind of shows that it can be very easily converted in this cycle. So by definition, magma is the molten liquid rock. If you're asking, well, what's the difference between magma and lava? Magma is the molten liquid rock, and lava is just that magma being released from the lithosphere. So lava is what you see coming out of the volcanoes. You're also going to hear me say the word pyroclastics. And pyroclastics are also another type of magma that comes out of the volcanoes. When I was down in Costa Rica, I visited Mount Arenal, and Mount Arenal was active about 10 years ago, a little less than 10 years ago, and then also in 1994, and when it erupted, it threw out these balls, giant, huge balls the size of a house or a building, called pyroclastics, that crushed the town of Arenal. Today, the town of Arenal is underneath a giant lake, and they moved the villagers that survived to another part of Costa Rica for them to live. And on days where the lake water is low, you can actually see the top of a church steeple. But I was able to go halfway up Mount Arenal and see the hardened lava. I was actually walking on the hardened lava, and I can show you some pictures of that we have when we're in class. Okay? So igneous rock is going to form when the magma cools, as we saw from the picture. There's two types of igneous rock: intrusive igneous rock versus extrusive igneous rock. Intrusive is where the magma cools very slowly below the Earth's surface, and that's what forms granite. You might have granite in your kitchens. Extrusive igneous rock is where magma is ejected from a volcano. So that's what, when I was walking on the cooled lava, I was walking on extrusive igneous block. Think of EX as exit, it's leaving. And this is what's going to form rocks that are known as basalt rocks. So sediments, I think you're familiar with this. These are rock particles, and these can be blown by wind or they can travel in currents in the water. When they settle, they can form sedimentary rock, and this is when they settle and they become very compacted or almost like cemented together, because there's minerals that are dissolving that are kind of acting like cement or a glue, and when they start to dry, so to speak, they begin to crystallize and bind together, so we get sedimentary rock. So a lot of our sandstone, our limestone, our shale is made up of sedimentary rock. There's a process called lithification. I'll try to say that 3 times fast. And this happens when sedimentary rock forms and traps living organisms in it and forms the fossils. And it forms through the compaction and crystallization. So this is where we get a lot of our fossils from, is this lithification process. Metamorphic rock, this is formed when heat or pressure on rock changes its form. So if we were to heat up rock that was already solid at one point and change that form, metamorphic means to change. That's what metamorphic rock is. And this happens at very high temperatures. And the high temperatures actually cause the crystals to reshape, and it can actually change the appearance of the rock and its physical properties. So 2 things that we get from that process is marble and slate. So marble is a heated and pressurized limestone. And depending on the limestone, you can get the different colors of marble. All right, and you've probably seen marble before. Slate, I was really fascinated when we were in Susquehanna County to see that there were slate fields where they have taken the slate from the mountains and they have them standing up in their thin sheets, and they use them, they sell them for people to use in building and making patios and all sorts of construction. This is heated and pressurized shale, and the shale is what they break through in order to get the natural gas in hydrofracking. You're going to hear me talk a lot about hydrofracking this year. Okay, so here we go. Here's some great pictures. So this shows intrusive igneous rock, and if you've ever been to Yosemite National Park, you've seen this before. So this is granite that you're looking at here. Here's extrusive igneous rock and the Canary Islands. I don't know if anybody's visited the Canary Islands, but you can kind of see how it looks like it was just melting down. This came out of a volcano and formed these layers, and this is the Canary Islands. So this is sedimentary rock, Arizona. If you visited Arizona, you might have seen this, and this is the sandstone in Arizona. And then this is metamorphic rock, and this is in Utah, in Nice in Utah. And you can see the different layers because of the changes that went on with the heating and cooling. Doesn't that look really kind of cool? So there are some obviously hazardous consequences from the plate tectonics that arise, and one of them I had mentioned already, and that's the Ring of Fire. And this is an area in the Pacific Belt where there's a lot of volcanic activity, and there's a lot of subduction zones that are going on, creating fault systems. A lot of earthquakes happen here. 90% of the Earth's earthquakes happen within this Ring of Fire, and we're talking about like the Philippines and Hawaii, that area. And it contains 50% of the Earth's volcanoes in this area. So here we go. Here is this Ring of Fire that you're looking at. Anything that you see that's a triangle, that is a volcano that you're looking at. This is Australia. So we've got Japan. This is off of, or Japan's up here. These are the Fijis, the Aleutian Islands, and then it comes running down all along the side of North America, and here's that Costa Rican area that we're talking about, and down South America that makes up that Ring of Fire. All right, we're going to end this here, and we'll talk about earthquakes in our next screencast.